Student page 102. We have an interesting set of problems here. We've got quantity x plus 3 divided by quantity x plus 3 equals 5. And then they ask us, does the quantity of x plus 3 divided by x plus 3 equal 1? Well, we certainly know we can't have two of the same thing. So let's go ahead and set our limits. We know that x plus 3 cannot equal 0. That's true for both of these. I'm just looking for a plus here. And that leaves us with x cannot be negative 3. Cannot be negative 3 in either case. And that's fine. I'm good with that. No negative 3s. All right. Can't tell it's a negative 3. That just looks like a 3. The loss is mine. There we go. That's a little better. Not really, but okay. All right. So if we're going to solve this problem, what we're going to do is we're going to take and we're going to multiply both sides by x plus 3. X plus 3 times x plus 3 over x plus 3. If you want, we can even make it look a little better. We can put this over a 1, and that's going to be 5 times x plus 3. Well, we can find ourselves a pair that is 1. This is the equivalent of 1, and we end up with 1 times x plus 3. That's x plus 3. And 5 times x plus 3, that's 5x plus 15. Well, let's see here what we got. I can subtract x from both sides. And I end up with 3 equals 4x plus 15. That's going to require me to subtract 15, or excuse me, oh, that's a 15, goodness. All right, so much for changing color. Minus 15, minus 15. 15, negative 15 plus 3 is negative 12 equals 4x. We got our 0 here. All right, and when we divide by 4, negative 3 is x. Another one of these. There is no solution. No solution. Because the condition contradicts the answer. That's okay. That happens. But that means probably, here, I'm going to make this negative work for me. Oh, I don't know. Anyway, that means probably this one's going to be a little better off. Let's see what happens. X plus 3 over x plus 3 equals 1. Multiply both sides by x plus 3. And we've got another 1, and we end up with x plus 3 equals x plus 3. The quickest thing to do, well, I think the thing that makes the biggest show is to subtract 3 from both sides, minus 3. And if you do that, what we get is x equals x, which tells us that x, it doesn't matter what x equals, there's no limit. X is any real number as long as x does not equal negative 3. Oh, does not equal. I got it. All right. A baseball player's batting average is calculated by dividing the number of times the player got a hit by the total number of times the player was at bat. Is it expressed as a decimal rounded to 3 places? After the first 10 games of the season, Samuel had 12 hits off of 33 at-bats. When we punch this into the calculator, what we get is we find out that his batting average is about 364. Notice the wiggly lines. That's because we rounded, so we're saying is about. We're not being really firm, so we didn't use those nice, straight, rigid equal sign lines that we usually do. That's what the question asks. How many hits in a row would he need to raise his batting average to above a 0.50? So we need him to get greater than, or we need him to get greater than 0.50. 0. All right, so how many hits? Well, he's going to add hits to his season. That means we're going to add in both places. 12 plus x over 33 plus x. It's amazing how quickly we can make a problem complicated, right? And we know one thing, we know x cannot equal negative 33, but the nice thing about that number is it's not likely to show up regardless of what we do. All right, so I'm going to go ahead and I'm going to multiply. I'm going to protect everything. You know, when I start getting crazy, I got to do that. So I'm going to multiply everything by 33 plus x on both sides. 33 plus x. Let's see what we get. All right, we got a nice, lovely 1. That guy's goner. Love it when they're gone. That's a good thing. That's what we're looking for. 1s and 0s. I keep telling you, it's going to be greater than half of 33. What is half of 33? I mean, 0.5 is half, right? So half of 33 is 16.5 plus 0.5x. All right, love my x's on one side or the other, and it looks like really be nice. I could subtract 0.5x on both sides. Oh, sorry about that. That's kind of ugly. I squished that in there. 0, and we get 12 plus, and this is a 1, so 1 minus a half, that's 0.5x is greater than 16.5. I'm going to go ahead and take the initiative of subtracting 12. Minus 12, minus 12, and we got 0.5x greater than 4.5. If I divide both sides by 0.5, we're going to get x is greater than 9. Now this is interesting because this is hits, and so really the thing is x has to be greater than 9, so 9 wouldn't do it. We want greater than. So our final answer is 10. That's the first number that's greater than 10. That's okay, we'll take it. Okay, now we're going to look at how many bats in a row without a hit would result in his batting average dropping below 0.03. So now we want it to get less than, gosh, that's not very nice. We want him to get less than 3.3. So he's getting no hits in a row. That means we start with that 12, that means we start with the 12 we began with, which is 12, and we add nothing to it. And then we're going to add, because he's not going to get any of them, but every time he misses one, we've got to add one. So now we're going to add x. So that's what our equation is going to look like. Poor guy. All right, so we have 12 over 33 plus x less than 0.300. All right. Well, I think you know the routine by now. Protect your binomial, 33 plus x and 33 plus x. Find your 1. There it is. There's my 1. And we get 12 is going to be less than 3.3. 0.3 times 33 plus x. All right, 12 is less than 9.9 plus 0.3x. So, ooh, I almost wish, you know what? I think I'd rather go 12 divided by 0.3. I think that'll be a lot easier. It's less than 33 plus x. And if I do that, what I find out is 40 is less than 33x plus x. And that means 7 is less than x. So he is going to have to miss at least 8 times. 8 misses. Basically, 8 misses will ruin his batting average. Poor guy.